Hello everyone, I'm Mrudula Chaukaskar from Bharati Vidyapit Dental College, Pune. Today I'll be presenting saliva, a diagnostic savior for diabetes. In this, we'll see aim, methodology, introduction, current investigations and the disadvantages. In saliva diagnosis, we'll see benefits of saliva biofluid, method of saliva diagnosis, mechanism of increase in saliva glucose levels, alterations in salivary composition in diabetic people, conclusion and references. Starting with AIM, this paper presentation aims to review the correlation of plasma and saliva glucose level and use of saliva as a biofluid for diagnosis of diabetes. Methodology: a thorough review of literature and statistical data was done regarding saliva diagnosis in diabetes. This review began with the search of relevant keywords linked with saliva, diabetes mellitus, diagnosis, etc. in various search engines including PubMed. Now, coming to our main topic, that is diabetes mellitus. As we all know, it is a group of chronic diseases characterized by insulin deficiency, cellular resistance to insulin action, or both, resulting in hyperglycemia and other related metabolic disturbances. The disease is associated with serious complications of the eyes, kidneys, heart, and blood vessels and other organ systems which may markedly impair quality of life and shorten patients' lifespan. India is the diabetic capital with significant number of patients with diabetes than any other nation. More than half of the diabetics remain undiagnosed. It is estimated that the count will increase up to 79.4 million in 2030. Today, investigations which are available for screening of diabetes are blood test and urine test. Now we'll see the disadvantages of each. Disadvantages of blood test. Number 1, it requires frequent invasion to vessels to collect the sample. Number 2, it is difficult to do in long-term diabetics due to development of finger callus, poor peripheral circulation, and risk of infection. Number 3, it is a painful and expensive test, and it causes anxiety to patients. Now, disadvantages of urine test. Increase in blood sugar levels needs to be large to be detected in urine. Number 2, urine accumulates over time and is therefore more difficult to collect under fasting conditions than blood. Owing to lack of sufficient diagnosis, diabetes and its complications are major cause of death worldwide. Therefore, there is a need for simple and non-invasive technique for the diagnosis and monitoring of diabetes. Saliva proteins reflect high blood sugar and associated disease processes long before appearance of clinical symptoms. A simple saliva sample can be used for diagnosis of diabetes mellitus, says the new research. But why saliva? What advantages do we get if we use saliva as a diagnostic biofluid? Let's see. Benefits of saliva diagnosis. Whole saliva can be collected non-invasively. It is a painless procedure. Sample can be collected by individuals with limited training. No special equipment is needed for collection of fluid. Collection of saliva is associated with fewer compliance problems as compared with the collection of blood. Cost-effective approach for screening of large populations can be done. Now, let's see how exactly saliva diagnosis is done. Patient is instructed not to eat anything overnight for at least 8 hours. Patients are provided with a container into which saliva is collected by spitting method. Evaluation of salivary glucose level can be done by glucose oxidase peroxidase method or Godpod method, or centrifugation of saliva is done and the supernatant fluid is examined by enzymatic method. Now, what is the exact mechanism behind increase in saliva glucose level? As we all know, glucose is present in the saliva of normal individuals. However, the mechanism of its secretion is still obscure. Many pathways have been proposed, but this is still an hypothesis rather than established theory. According to Marva Rao et al., persistent hypoglycemia alters both blood vessels and basement membrane permeability of salivary gland. This leads to an increase of glucose percolation as well as other small molecules like urea, which are not secreted by salivary gland from blood to saliva through gingival crevices. As a result, the glucose levels in the saliva increases. Now let's see the alterations in salivary composition in diabetic people. Saliva screening showed an altered salivary composition in people with diabetics comparing to controls. A significant increase of the majority of parameter concentrations such as glucose, urea, amylase, total protein, and electrolytes, including potassium, calcium, and chloride in diabetics compared to controls. Researchers have proved the significant relationship between salivary glucose concentration and associated glycemia values. However, total IgA concentration was found to be significantly low in diabetics compared to controls, which makes them more prone to pathogens. A significant increase in the all salivary electrolytes levels such as calcium, chloride, and potassium in people with diabetes. Electrolytes play a role in dental health, particularly calcium in enamel remineralization. Researchers say that all these alterations would be due to a compromised salivary gland function caused either by autonomic neuropathy or basement membrane harm, particularly in poorly controlled diabetes. In conclusion, results show that diabetes leads to a consistent increase in salivary glucose that remains detectable. This review reports number one, a significant overall relationship between salivary glucose concentration and associated glycemia values, with the correlation strength increasing as we move to higher glycemia values. Number two, a significant correlation between salivary and blood urea levels has also been proved. Also, researchers say that gender does not play any role in the occurrence of diabetes mellitus. These results, in combination with recent and old reports, support the possible use of salivary glucose as diabetes biomarkers. The simple and non-invasive collection of saliva samples is an important advantage that supports the usefulness of this fluid as a diagnostic tool compared with serum. However, more studies are needed to be conducted in the future. Even if at present, due to several limitations, salivary glucose per se may not show enough consistency to be used as an independent and autonomous diabetes biomarker, the results suggest that it provides valuable information and may in the future be combined with other salivary biomarkers to create an effective high specificity and sensitivity diabetes large-scale screening system. Till that happens, taking the changes of these salivary parameters into account can be useful for better therapeutic aims in diabetic patients as well as the possibility of reducing the risk of oral diseases in their follow-ups. These are my references. Thank you.